Oh boy, statements and reasons still there. Statements and reasons will still be activated. You're just going to have to doing those statements and reasons today. It's a little something new. Before I get into the new type of proof, you know what contradiction means? Contradiction can't happen at the same time. Two things, or more, I guess more, but two things that cannot happen at the same time. It's really impossible to happen at the same time. They contradict each other. So I have three up there. PQR, they're coplanar, they're collinear, and then angle PQR equals 60. Two of those can't happen at the same time. They contradict each other. Find them. Find them within your group right now. Two statements that geometrically impossible to happen at the same time. Which two cannot happen at the same time? Therefore, they contradict each other. Hey, what did we find? Did we find the two contradicting statements up here? Did we, 17, find them? 2 and 3. All right, why? What did collinear mean again? Going all the way back to Unit 1, collinear. On the same line, but if you have an angle, PQR, those are not on the same line. Okay, so they can't be collinear and an angle that's 60. They could be collinear and an angle that's 180, but not 60. So that's what's going to happen in your proof today. Eventually, you're going to have a contradiction somewhere in your proof. And you're going to be like, how can that be? Now, I have all these beautiful steps here that we could read through, and this is how you do an indirect proof step by step. But you know what? Let's just jump right into the fire. Let's go right now. All right? It's the only way this is going to get done. No excuses. Here we go. First thing, right off the bat. What's different? What's different than anything we have seen all year long? Izzy, one thing that's different. Yeah, when have I ever asked you to prove something's not equal? Never. And it's all givens, too. All right, so whoa, time out. Prove something not equal. Right there, tells me, because I'm asked to prove something's not equal, that this proof has to be done what's called indirectly, which is slightly different than the ones we've been doing. It's still going to be done in 2 columns, statements and reasons. All right, but you're going to have a couple extra new reasons in there. Okay? And just please stay with me through this first one. It's awkward, it's uncomfortable, but at the very end, I wrap it up in a nice bow for you. All right, here's how we're going to start it. What have I been telling you all year long about your givens? Use them, and they're always true. Okay? So both of these givens I have up here, those are true. All right, and I say that, you'll see why in a couple statements. The second step now, in our indirect proof, we are going to assume the opposite of my proof statement is true. What's the opposite of A not equal to C? So we are going to assume that they are equal to each other. And the reason is assumption. We're going to assume that A is congruent to C. And I want you to be patient and see where that leads us. By assuming that those 2 angles are true, that's going to get me into some dicey territory. All right, a place we do not want to be. All right? So mark that in your diagram. We can treat that as a given, A congruent to C. And we also have another given we can mark, which was AB and BC are equal. Here's what I want you to do. Find a pair of triangles we can prove congruent. Find a pair of triangles that contain A and C as full angles and AB and BC as full sides. You guys have the power to do that. This is nothing new now. Can you find a pair of triangles we can prove congruent? Hopefully we can. Use the angles and the sides we already have. Can you find a pair of triangles that we can prove congruent? And just a refresh here, I don't have time to ask people, but side, 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 angle, side, angle, side, angle, 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 side, and HL. Did you guys find a pair you can prove congruent? Did we find a pair? Are they overlapping, I hope? Good. I'm hoping it's BDA or BAE, excuse me. That one, BAE with BDC, this one. Because you have a full side, full pair of angles. I'm missing a pair of something, though. Missing a pair of something. I got the sides and an angle. What am I still missing here? I don't want to call on numbers, but what am I still missing? What's congruent that I could do right now? Angle B, reflexive to itself, right? Because it's a full angle in both. All right, ready? Angle B, congruent to itself, reflexive. All right, that should make the triangles congruent. And I know you have no idea where this is going, but it's going to go there. BDC is congruent to BEA. I am going to ask somebody what the method is. Why are those two triangles congruent? 15. Nice job. Okay, where am I going with all this? Well, if the triangles are congruent, what do we usually do next in every proof? We say either a pair of sides or a pair of angles are congruent, right? Guys, in my blue triangle up there, side BD in the blue triangle, side BD matches up with what side in the yellow one? Wait, wait, what? Oh, what? What? So you're saying BD and BE match up. And because the triangles are congruent, those two sides have to be. Your paper might catch on fire right now. Why is that statement true? By CPCTC, and I'm scared now. I'm real nervous. Look at your proof. Look at my proof. Something's wrong here. What's the issue we're having? The given said they weren't, and you just proved them they were. That's a little something called a contradiction, isn't it? Okay, so that can't be true because the given said they weren't equal. Watch the flow now. That can't be true. What started the journey here to let us to step 5? By doing what? Assuming A was equal to C, right? Well, that's got to be false, all right, because it led us to this contradiction here, which we know is false as well. So if that's false, ready? Ooh, hey, settle down. Our assumption is false. Our assumption is false. So if A is equal to C is false, what's got to be true? The opposite of that, which is A is not equal to C, all right, which is what we needed to prove. All right, one last time. I'll go a lot slower now. What do we know about this statement? What do we know about BD being equal to BE? That's false. In the givens, said they weren't equal. So that's false. All right, don't write this in. I'm just flowing here so you guys can see it. That's got to be false. What led us to here? What started us to get here? The assumption, which also has to be what then? If that statement is false, give me a true statement then. The opposite. Angle A is not equal to angle C. And that's what we ended up proving. We needed to prove. The reason? Here we go. Assumption. Bless you. Led to a, well, more than that. Led us to a contradiction, right? Oh, we're on fire today. I'm sick. We're not done yet. Prove to me that you know where this contradiction is. So I need to know the steps, step numbers where the contradiction occurs. So where is the contradiction up here? Well, it started with this, right, in statement 1. And where did you contradict that? Which statement? Statement 5. Right below assumption led to contradiction. 1 and 5, that's where your contradiction is. Okay? Everyone always thinks it's the assumption and the last step. That's not your contradiction. That's what you needed to prove. Here is your contradiction that led to it. Okay, take a breath. Let's just refresh and summarize what we just did. Number 1, why do I know I have to do this indirectly? You're ready to tackle a proof. How do you know it's got to be done indirectly? Proof statement says something's not equal. First step, other than your given, is your assumption. Where does that come from? The proof statement. Opposite of the proof. And along the way, somewhere in your proof, you are going to contradict one of the givens. Isn't that what I just did? Didn't I contradict one of the givens? All right, that's the goal. In every indirect proof, you are going to contradict one of the 2 or 3 or 4 givens that are provided. Okay? As you always know in here, 1 does not make you great. Drama. Why am I doing this one indirectly? Other than it's the topic of the day. There it is, right there. I read the proof statement. Oh, you want me to prove something's not happening? I'm doing this beast indirectly. I already wrote in your givens. Next should come your assumption. What are we going to assume is true in this proof? Here we go. Whoa, settle down. 16, what are we going to assume is true? BD bisects AC. And remember, use it. Use it. Mark on your diagram what that leads to. Put it in your proof eventually what that leads to. All right, before we get to step 3, let's have a goal. You need to contradict something, right? Look at your givens right now. How many givens did I provide? How many? 2. You need to contradict one of them. So look at the 2 givens right now. Which one do you think it's going to be the easiest to contradict? Jenna? The not isosceles. How are you going to contradict it? By proving? How do you contradict it's not isosceles? It is isosceles. So that's your goal right now. Get A, B, C isosceles. And then you contradicted your given. Okay? This is nothing new now. This is nothing new by proving it's isosceles. What wins a triangle isosceles? 2 sides, or I could go crazy and go 2 angles. Woo, that's big time. Get me there. Get me there. Get me 2 sides or 2 angles. So I'm going to open it up to anybody. Get me 2 sides or 2 angles. Get me along the path. 12, let's roll. Ooh, boss, I like it. AD congruent to DC. Why is that true? Good, he's using his assumption to his advantage. Yeah. So it looks like he has us on the path of proving these 2 congruent. So I can get the sides or angles. Next. 8. Oh, you taking the easy way out. Ooh, here's a Unit 5 vocabulary term we have not used yet. Huh? BD is an altitude. Anybody remember? Beginning of the unit, what an altitude does? Comes from a vertice and is what to the opposite side? Which means it forms a... Whoa, look at you kids. Acting like you know something. Good. So I could say angle BDA and angle BDC are right angles. Can we talk a reason here? I don't want to say perpendicular lines form right angles because I didn't mention anything was perpendicular yet. How'd you know it was form a right angle? Because this was an... Okay, so definition. Or you can say altitudes form right angles. That's also an acceptable one. Oh, you guys are a little rusty. I found out from my period 1 class, they're a little rusty with the proofs. I still need to say what about the right angles? Yeah, don't forget that. Had a lot of people mark that they were right angles last period 1 job. Stop being an embarrassment. You were raised better than that in here. Angle BDA congruent to BDC. All right angles congruent. Whew, a lot of steps here. Pace yourself. Hopefully you didn't go out too quick. I think I have everything, right? To prove them congruent. I think so. So BADA. Whoa. Two triangles are congruent. What do you got for a little method? Oh boy, huge here. 6. We've been having a good day here. Way to keep it going. You were rattled at the beginning there, Mike. I could tell, but then you picked it back up. Nice job. Why do you needed the triangles congruent? Yeah, CPCTC. Now you got a choice here. You can go basic or you can just go nuts. 2, what do you want to prove congruent? Remember, we're trying... Oh. Basic. Got it. That would make this triangle now. It's isosceles. Yikes. Again, be careful. Make sure your paper doesn't catch on fire here. Why is it isosceles? What's your reason going to be? In this case, anyway. Uh-oh. 7. How do we know it's isosceles? In a triangle. 2 sides congruent means isosceles triangle. Uh-oh. What did we just write there? What did we just write? Oh, shoot. It said it wasn't isosceles. What led us to it being isosceles? My assumption. So that bad boy's got to be false, which means the opposite. BD does not bisect. Has to be true. Assumption. There is no abbreviation for this, by the way. I had one class a couple years ago. Hey, let's do ALTAC. Assumption led to a contradiction. How about we don't? How about we stop being lazy? Come on, ALTAC, get it? Yeah, I get it, but no, that's not a thing. Whoa, where's your contradiction? Step 1, the given, and where'd you contradict it? By saying it was isosceles in 9. Nice job. All right, final thing you got to do here for me. You're going to start the homework, but I would like to see the first one when it's done so I know you're on the right track. Okay, so put your paw up when you're done. I'll come over, take a look at it, make sure you're not missing any steps.